how the photon has momentum, but without mass. What's the problem? Classically, momentum is defined as momentum is mass times velocity. But the photon has zero rest mass. Does that mean it has zero momentum? No, it doesn't. In fact, Broglie found that the momentum is inversely proportional to its wavelength. How does that happen? Einstein knew that the speed of light is the same in all directions and deduced that the physical laws are invariant in all inertial reference systems. E equals mc squared. But this is relativistic mass, and it has two components. One is rest mass, and the other is dynamic momentum. And the result is that when the rest mass is zero, the energy is equal to the momentum times the speed of light c. And the momentum then is given by de Broglie, and that is equal to the relativistic energy divided by c. So any change in energy, such as inelastic scattering, causes a corresponding change in momentum. And this change in momentum is due to this dynamic motion. A little bit more about the quantum. It's a wave particle. Here's a wave. It's due to Maxwell's equations. Electric vector in the vertical plane, magnetic vector in the horizontal plane. Has a phase velocity Vp. And it is enveloped by a normal distribution with a different velocity group, different in principle, but in fact in light, where the mass is zero, the group velocity is equal to the phase velocity. From this we can derive the uncertainty, which is roughly the full width half maximum. I will not say anything more about that for today. But let's look at rest mass. This is a rest mass of a massive particle. But the photon has zero rest mass, and the energy is proportional to the momentum. Here's the group velocity, zero at low k, and limiting to c in relativity as it goes faster and faster. The rest mass is Newtonian, but the mass increases with speed in relativity. And the phase velocity is the inverse of the group velocity. Mass has two components. One is the rest mass, which is a function of the phase velocity, and the other is the dynamic mass, which is a function of the group velocity. So we have the relationship. We know how momentum arises in the photon where the mass is zero. Momentum, just to note, is more complicated in massive particles. The rest mass m0 depends on the phase velocity. The relativistic dynamic mass depends on the group velocity. These facts are summarized in these two videos. And the final conclusion is any change in energy, such as inelastic scattering, causes a corresponding change in momentum, with a reference to the physical journals.